So let's say we have this limit, the limit as x approaches infinity of x cubed over e to the x. And this might be intuitively solved by just saying that as x gets bigger and bigger, x cubed grows faster than e to the x. But let's try to solve it mathematically. And since it's a fraction, if we plug in infinity and we get infinity over infinity, this is in indeterminate form, which means we can use L'Hopital's rule. So let's try to do that. So the derivative of x cubed is 3x squared, and the derivative of e to the x is still e to the x. And we're taking the limit as x approaches infinity. And now we use L'Hopital's rule, but still, if we plug in infinity for x, we still get infinity over infinity, meaning this is still in indeterminate form, and we don't know our answer yet. And what we can do is use L'Hopital's rule again. So for a second time in the same limit, and change this to 6x over e to the x, and limit as x approaches infinity. And this is still infinity over infinity, but we can do it again for a third time, and we get 6 over e to the x, the limit as x approaches infinity, and we get 6 over infinity, which is just 0. That's our answer. So yeah, and this is not necessarily a new concept. If you already know L'Hopital's rule, this is just the same stuff, but a lot of people tend to forget or just don't know that you can use L'Hopital's rule multiple times in one limit. Now let's do another example. Let's say we have the limit as x approaches 0 of ln of 1 plus x minus x all over x squared. And first let's try direct substitution. Let's insert 0 for x, and we get 0 minus 0, which is 0, over 0, which is indeterminate, which means we should use L'Hopital's rule. And differentiating top, we get 1 over 1 plus x minus 1 all over 2x by differentiating the bottom. And instead of just taking it like this, let's multiply both the numerator and denominator by 1 plus x, so we don't have this double fraction, or the fraction inside a fraction. And we get 1 minus 1 plus x, which just simplifies to negative x, all over 2x times 1 plus x, and that simplifies to 2x plus 2x squared. And now we take the limit of this. Well, we can just substitute 0 into here, and we also get 0 over 0, which means we should use L'Hopital's rule again for a second time. And differentiating this, we get negative 1 over 2 plus 4x. We're taking the limit as x approaches 0. And now when we substitute 0 into this, we get negative 1 over 2. And that's our final answer. Now let's get into some practice problems. If you think you know how to do this one, then pause the video and try it. This one says to evaluate the limit as x approaches 0 of sine x minus x all over x cubed. And first off, what you always need to do first is plug in 0 for direct substitution and make sure it's indeterminate. So sine 0 minus 0, that's just 0, and x 0 to the power 3 is 0, so 0 over 0, which means it is indeterminate, which means we can use L'Hopital's rule on this. And we get cosine x minus 1 all over 3x squared, the limit as x approaches 0, and again, plug in 0 to make sure it's indeterminate, or if you get an answer. So cosine 0, 1 minus 1, 0, 3 times 0 squared is 0. So we have to use L'Hopital's rule again for this one. And we get negative sine x all over 6x, the limit as x approaches 0. Now let's try plugging in 0, negative sine x, 0 over 0. We still don't have an answer yet. This is still indeterminate, so we're going to have to do this again. And negative sine x is, the derivative of that is negative cosine x, and 6x turns into 6. And if we take the limit as x approaches 0 of this, we get -1 over 6, and that's our final answer. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and try it. This one says to evaluate the limit as x approaches infinity of ln x over the square root of x. And as always, the first thing you need to do is direct substitution. And for this one, we get infinity over infinity, which is indeterminate, which means we can use L'Hopital's rule. So let's use it. Ln x becomes 1 over x, and square root of x becomes 1 over 2 times the square root of x. And this is equal to 2 times the square root of x over x if you just multiply both sides by 2 times square root of x. And again, we're taking the limit of this. So let's rewrite it as the limit as x approaches infinity. And now we can use direct substitution again, but we still get infinity over infinity, which means it's indeterminate, which means we have to use L'Hopital's rule again. And we get 1 over square root of x over 1, which is just 1 over square root of x. And we're taking the limit of this as x approaches infinity. And if we use direct substitution this time, we get 1 over infinity, which is 0. And that's our final answer. So everything that I explained in this video and all the problems that I went through should teach you everything that you need to know to use L'Hopital's rule multiple times to evaluate limits. If you learned something from this video or if you enjoyed it, then please consider liking and subscribing.